Okay, imagine an artificial intelligence so incredibly advanced at finding and exploiting software vulnerabilities that its creator couldn't just release it to the public, right? When OpenAI finished its latest model, they actually had to run the release by the US government. And that resulted in a highly restricted preview to roughly 20 carefully vetted, individually approved organizations. Just 20. That unprecedented number of partners initially gained access to the highly classified capabilities of GPT 5.6.
So, welcome to today's Explainer. Today, we are unpacking the massive structural shift in how frontier AI models are deployed, priced, and utilized in 2026. Because, this isn't just about a model getting slightly smarter, it's about a complete reimagining of AI architecture. We're talking about shifting from a single monolithic intelligence to a dynamic, multi-tiered operating system. Let's look at how GPT 5.6 actually works under the hood.
Okay, let's dive into this. Here is our roadmap for navigating this dense, new ecosystem. We're going to cover the government-gated frontier, the three-tiered architecture, programmatic tools and caching, subagents in ultra mode, and finally, the routing layer reality.
Part 1. The government-gated frontier. Let's talk about that restricted preview.
The reason this release was treated with such unprecedented caution is, well, pretty clear when you look at the numbers. On SEC Bench Pro, which tests defensive threat modeling and code review, GPT 5.6 Sol scored 71.2%. That completely blows past its predecessor's 45.8%. And then on Exploit Bench, which is an offensive security evaluation, it jumped from 47.9% all the way to 73.5%. Basically, it's matching top-tier offensive security platforms, but utilizing roughly one-third of the token volume. This massive leap in both offensive and defensive cybersecurity capabilities meant a public waitlist simply wasn't an option on day one.
Moving right along to Section 2, the three-tiered architecture. Meet Sol, Terra, and Luna.
For years, we kind of thought of AI as a single construction worker, right? You give it a task, it does the task. But now, OpenAI has essentially built a general contractor. Now, what's really interesting here is how they've segmented pricing and capabilities without compromising on memory. You're looking at a family of three variants, Sol, Terra, and Luna. And all three share an absolutely massive 1.05 million token context window. However, the costs scale depending on the compute you actually need. Sol, the flagship, sits at $5 for input and $30 for output per million tokens. Terra is exactly half that price, at $2.50 and $15, and Luna, the high-throughput tier, drops all the way down to just $1 and $6. So you aren't forced to pay a massive premium when your task just doesn't require frontier intelligence.
Now, while Sil gets all the flashy headlines, Terra is arguably the strategic center of gravity for modern enterprises. Why? Because it offers performance that's competitive with the previous generation's flagship, GPT 5.5, but at literally half the cost. It becomes the ultimate everyday production default. For things like retrieval on rented generation pipelines, processing big business documents, or running customer-facing chatbots, Terra provides robust quality without breaking the bank. It is absolutely the workhorse of the new lineup.
Section 3. Programmatic tools and caching. How interactions are evolving.
To support this whole tier system, the underlying mechanics of how the model interacts with your data really had to evolve. Let's define one of the most powerful new upgrades, programmatic tool calling. In the past, if a model needed to use multiple tools, it required this constant back-and-forth communication with the developer's server. Now, the model can actually write and execute its own JavaScript within an isolated V8 runtime to coordinate tools independently. And crucially, it does this securely. The runtime has no direct network access or general file system access, which keeps enterprise data strictly contained.
Here is exactly how that plays out, step by step. First, the model assesses a complex prompt and writes a temporary JavaScript program. Second, it calls all the necessary tools in parallel rather than one by one. Third, and honestly this is the magic part, it processes and reduces all that intermediate data internally. Finally, it returns only the synthesized final output to the user. This literally saves developers from repeatedly prompting the model and drastically reduces token overhead for those really complex tasks.
And this brilliantly illustrates the new FinOps, or financial operations reality, of working with GPT 5.6. Prompt caching is now explicitly predictable. So when you commit input tokens to memory, a cache write, you pay a premium of 1.25 times the standard rate. But when you reused context from that cache, you get a massive 90% discount. This really rewards developers who build applications that intelligently reuse system prompts and context, making heavy workflows economically viable.
Section 4.
subagents, and ultra mode. Let's look at the flagship Sol tier.
Okay, this is where we look exclusively at what that flagship Sol tier is truly capable of when the training wheels come off. For the most intense, long-horizon tasks, Sol introduces something called Ultra Mode. Instead of reasoning through a complex problem linearly, one step at a time, Ultra Mode deploys 4 separate subagents simultaneously. They work in parallel to execute complex terminal commands, review code, or analyze deep research, drastically accelerating agentic workflows. It's like a giant puzzle being put together by 4 people at once instead of just one.
Looking objectively at the data on Terminal Bench 2.1, which tests command line agentic workflows, we can see the tangible impact of this architecture. Anthropic's Claude 5.5 puts up an impressive 88.0%. The standard GPT 5.6 Sol edges it out at 88.8%. But when you activate those parallel subagents with Sol Ultra, the score jumps to a state-of-the-art 91.9%. For heavy software engineering environments, that parallel execution is for sure a distinct advantage.
However, looking at the broader picture impartially, capability at the frontier is entirely task-specific now. GPT 5.6 solid undeniably leads in complex coding orchestration and those critical cybersecurity benchmarks we discussed earlier. Yet Cloud Fable 5 maintains a highly competitive edge in other domains, leading in deep physical sciences, graduate-level general knowledge on the GPQA Diamond exam, and software engineering tasks on SWE Bench Pro. So there is no single best model anymore. The winner depends entirely on your specific workload.
Finally, Section 5, the routing layer reality. Let's talk about deploying AI in 2026.
So what does all of this mean for you, the developer or the enterprise architect? Well, this quote from our sources beautifully summarizes the current landscape. The frontier is no longer just raw intelligence, it is intelligence you can route, cache, parallelize, and afford. We've officially moved past the era of just throwing the biggest, smartest model at every single problem.
So the crucial point is that deploying AI is now an exercise in routing. The smartest strategy? Build a triage layer. You route your high-volume, simple tasks, like basic text classification or data extraction, to Luna to save money. You make Terra your default for scalable production and everyday chat. And you only escalate to Sol, paying that premium, when you hit a wall that requires hard reasoning, deep cybersecurity analysis, or multi-step agentic workflows.
I'll leave you with this final thought to ponder today. As you build your next workflow, ask yourself, are you simply prompting a model, or are you managing an ecosystem? The architecture of GPT 5.6 proves that the future belongs to those who understand how to orchestrate intelligence, not just summon it. Thanks so much for joining me on this explainer, and I hope it completely shifts how you think about deploying frontier AI.